Hello, welcome to the third video lecture on mechanics of materials. Let us learn stress-strain curve for mild steel in this video lecture. As a recap, we have seen some introduction topics about mechanics of materials, classification of mechanics, difference between deformable and rigid bodies, definitions of stress, strain, structural members. We have seen few pictures, beams, columns, etc. Let us learn stress strain for mild steel. How do we study the behavior of mild steel? So that is by conducting an experiment of mild steel in universal testing machine. A cylindrical workpiece, a specimen of mild steel, we will fix between the jaws of the universal testing machine and a gradual load is applied. The load is measured using a dial gauge, and whenever the deformation happens, that deformation is measured using an extensometer. Okay. So load versus deformation data will be observed, which can be converted into stress versus strain. This experiment will be carried until the specimen breaks into two pieces. So then from the graph, various parameters have been you can observe. Okay. Let us look at a video and study, understand the stress strain curve or conduction of the experiment.
Let's do a small experiment to understand the stress strain curve. You see this thin steel wire? Let's see how its deformation happens. On the right, you can see the stress versus strain curve of the steel wire. Now, when the steel wire is under continuous tensile stress, as expected, it elongates. Now, look at the graph. The elongation is linearly proportional to the applied stress. So, this region in the graph is what it is. If the stress, that is the load, is released, what will happen? See there, the steel wire gets back to its original length. Now, within this stress limit, the steel wire follows Hooke's law. What it means is the deformation is elastic. Now, let's increase the load further. And what do we see? After a certain point, look at the graph. The wire is not following Hooke's law. That is, stress is no longer proportional to the strain. But if you release the stress, the wire still goes back to its original length. The limit of this behavior in stress strain curve, that is this point, is known as the yield point. Now, if we increase the stress further, the strain will also increase, no doubt. But it will not follow Hooke's law. What it means is, even if there is a very small increase in stress, the deformation will be much more, and the wire will not return to its original length, even after we release the stress. So in this range, we can say that the deformation is plastic. And what happens? You increase the stress further, as expected, the wire will ultimately break, and that is the breaking point.
Thank you for watching.